Okay, so in hypothesis testing, we obviously have to set up a hypothesis that we want to test and potentially reject. So the status quo hypothesis is known as the null hypothesis. We're going to be denoting it as H0. And the null hypothesis is typically the hypothesis that will contain the equal sign. So for example, it might say that the mean is equal to 0. I'm probably hoping to discover that the true mean is different from 0. Now, different means that it is either greater than 0 or less than 0. So as my alternative hypothesis, denoted as HA, I might have something like mu is not equal to 0, right? So this would be an example of what's known as a two-tailed test, right? Because if I were to reject the null, I would be rejecting the null either if the mean is greater than 0 or if the mean is less than 0, right? So this is the first type of test we may have to perform, which is a two-tailed test. The second type of test that we may have to perform is a one-tailed test, right? So in a one-tailed test, we're going to be using the crocodile sign. So we might say that mu is less than or equal to 0 as our null hypothesis. Notice again how the null must contain the equal sign, even though it also contains the less than sign. And our alternative hypothesis might say mu is greater than 0. So in this case, I will only reject the null hypothesis if I end up in the right tail of the distribution. So just in terms of basically visualizing that, let's actually first visualize this example. So I've got the distro, right? I've got the distro. And let's say it's a kind of normal looking distro. And I will obviously have two tails. So I'm going to have a tail here and I'm going to have a tail here. And there'll be a certain probabilities in this tail. Now, these probabilities are known as the significance level. And the significance level is denoted as alpha. And alpha is sometimes expressed as 1 minus confidence level, right? I'm giving you quite a lot of stuff here, my friends. So if I said I'm performing a test at the 5% significance level, that's the same as saying I'm performing a test at the 95% confidence level, right? Because 1 minus 95 is going to give us 5%. So let's say I was performing a two-tailed test. I'm performing a two-tailed test at the 5% significance level. Well, I'm gonna have to split that 5% probability across two tails. So this left tail will have 2.5%, and this right tail will also have 2.5%. And these tails, these probabilities, will then determine my left critical value, which is negative critical value typically, if we're using the Z or the T, and the positive critical value is to the right, but they are symmetrical, right? And they're going to be determined by the significance or by the confidence. Now, if on the other hand, I were performing a one-tail test. Now let's have another distro here. Okay, so if it's a one-tail test, then perhaps I only consider the tail to the right. In this case, the alternative tells me which tail I'm interested in. So I'm interested in the tail to the right. But once again, I am performing a test, let's say at the 5% significance level or the 95% confidence level. And that is telling me that now the entire 5% is in this tail, right? And therefore, that's going to affect my critical value. Okay. So then in statistics, sometimes we're going to make mistakes, and these mistakes are known as type 1 error and type 2 error. Let's go to the Word document and define those things. Okay, so what is a type 1 error? When the null hypothesis is true, but we incorrectly reject it, right? Or this is also known in statistics as a false positive, right? We have a false positive result, okay? So to give you an example, perhaps our null may be that a person is innocent until proven guilty. Okay, that is our null. Null is person is innocent. However, let's also assume that the person is indeed innocent. However, the courts incorrectly convict the person, right? So assume the person is indeed innocent. However, the courts incorrectly convict the person. So that is a false positive because our null is the person's innocent. Then the person was indeed innocent, but the courts incorrectly convicted him. Okay, so that's a type 1 error. The probability of making a type 1 error is equal to the significance of the test, i.e. the alpha. Now, and we can easily see that by observing that we can only reject the null if we are somewhere in the rejection tail, right? And what was the probability of the rejection tail? Well, that was 5%. That was our alpha or significance of the test.